Okay, so this is sample assessment of Unit 6. So question number 1 says a series of tests were carried on a pale green. On a pale green inorganic compound A, which contained two cations and one anion. Two cations and one anion. Okay. Dilute sodium hydroxide solution was added drop by drop to 5 cm cube of an aqueous solution of A until there was no further reaction. Okay. So a green precipitate was formed which was filtered off
Mm.
and after some time turned into a brown solid. Give the formula of the cation in A shown
Fe2
by
plus,
this test. How?
because it's green in color, and
Exactly, it was
Fe3
pale
plus will
green.
be
It was pale green, yeah, and after that it turns into brown. So Fe3 plus is brown, isn't
yeah,
it?
so that'll be Fe3
Yeah,
plus. Yeah,
yeah, exactly. It would be Fe2 plus, right?
yeah.
Or Fe3 plus. What do you think? Should I write Fe2 plus or 3 plus?
Fe2 plus is for green, and
Yeah.
Fe3 plus will be for the brown.
So what should I write?
So give the formula of the green precipitate. Uh, oh, formula of the
Give the
cation.
formula of the cation in A shown by this test. After the reaction, I got the brown precipitate. After the reaction, after doing the test, so what was the precipitate initially? So it was Fe2 plus,
Yeah,
right? Yeah. So we have to write
yeah.
down Fe2 plus. Give the formula of the green precipitate. When I was added sodium hydroxide, so of course iron hydroxide were formed. So so I'm
So
supposed to
wait, wait,
write,
wait. Fe H2O4
yeah,
OH2 2 plus. No, 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 no,
good.
no charge, no charge.
No charge. Why?
Because
Because this is
H2O is neutral.
-2 and +2, right? And this is
Yeah,
0.
yeah,
Yeah, that's
yeah.
why. And there should not be any charge because they are asking precipitate. Precipitate is solid insoluble substance. There should not be any charge.
Oh, yeah, yeah.
Yeah,
Yeah.
that's why. So identify by the name or
Identify by the.
formula. Brown solid. Oh, that's easy.
So brown solid means it will also not have a charge.
Yep.
So because this is Fe3 plus, of course, but you have to tell the brown solid. So Fe H2 nahi, H2O3 OH3, is it correct?
Yeah. This is -3.
Yeah.
This is +3. Again, there should not be any charge.
Yeah.
Okay. Because the
So
iron is
yeah.
+3 because this is brown solid. So that's why we have written OH3. And if this is OH3,
Mm,
so the total coordination number is 6. Like the total number is 6.
mm.
So I'm supposed to write this one. Yeah. Okay. Then
Oxidation. This is oxidation.
oxidation. Why this is oxidation? Charge is increased. That's
The
why.
ox No, no, no. The oxidation number changes from +2 to +3. It increases, so that's why it's oxidation.
Yeah, that's why charge is increased, right?
Yeah. No, the oxidation number.
Yeah, the same thing.
Yeah. Okay. Um, Give the reason why the dilute sodium hydroxide is added drop by drop when testing for cations. Mm,
Very good question. So 1 mark, of course, it's a concept.
mm. Give the reason why dilute sodium hydroxide, okay, is added drop by drop when testing for. Okay, when testing for cations, because if it exceeds, no, if it is added in excess, another product might be formed.
Basically, the thing is that whenever we are going to test anything, and we
Hmm.
always add few drops and then we add in excess. So first of all, of course, there are some possibilities. There may be the formation of precipitate, or there may be the, you can say, a simple solution, a clear solution is formed. So let's say if in any chemical reaction, when you will be adding sodium hydroxide drop by drop, okay, and
Hmm.
it has to form a precipitate, but suddenly, like initially from the initial, you are going to add in an excess. So you know what would happen? You will not be able to notice the formation of the precipitate.
Hmm.
You will not be able to notice the formation of the precipitate. So then you will be having the wrong observation. So that's why first of all you have to write down the like you have to add the drop by drop
Hmm.
until the precipitate is formed. And when the precipitate is formed, then you have to further test it
Yeah.
until after adding an excess solution. Then you have to see PPT will remain or PPT
Dissolve.
like will be soluble. PPT
Yeah.
dissolves.
Yeah.
Okay, so that's why. So what should I write?
Um, the give the reason by dilute sodium hydroxide. This is done to ensure the formation of precipitate.
Oh, if a PPT forms as a product, so it may dissolve. It may dissolve in an excess. Okay. Okay, the
One second.
filtrate was heated gently and an
No, one second. If
alkaline gas. Yeah.
one second. If a precipitate is a forms as a product, it is also as a product. It may dissolve in. Yeah.
Okay. Say this one.
The filtrate was heated gently and an alkaline gas was given off. Describe a test and its positive result to show that the gas was alkaline. Place a this thing, uh, litmus paper, litmus paper at the mouth of test tube,
Mhm.
mouth of test tube. Um, color changes from this thing, red to blue, right?
Color changes from what? Red to blue.
Alkaline, right?
Yeah.
So red to blue, right?
Yeah. So basically, like what is the, like you can say, alkaline gas, what it should be?
Ammonia.
Ammonia. Yep. And I'm supposed to write, you can say, take damp, a red litmus paper. Why we are taking damp?
Um,
Why not a
not
dry,
really.
why not a dry litmus paper?
Not sure.
Because ammonia will absorb in that. Okay, so it would be
Okay.
giving you easier test. Otherwise, ammonia will not be absorbing in a dry paper, so it would not be giving you a positive result.
Okay. Got it.
So take damp red litmus paper on the mouth of test
Test tube.
tube turns from red to blue. Turns into red.
Uh, yeah, turns from red to blue. Yeah,
Sorry, turns into blue. Sorry.
yeah,
B for base, B for blue.
yeah.
Okay, describe a further. Oh my God. Okay.
Um, Further chemical test and its result to confirm that the gas was ammonia. Hmm.
So very good. Very good. It's related to, if I relate it, if you remember, in IGCSE, we used to discuss glass, the glass one question, like the glass tube. If you remember, it's related to the diffusion. On the left hand side, I have ammonia. On the right hand side, I have HCl. He used to ask at which point they are going to meet point A, point B, point C, since the molecular mass of ammonia is lower, that is 17, and the molecular mass of HCl is 36.5. Since the mass of ammonia is lower, it would be diffusing faster, and the mass of HCl is higher, it wouldn't be diffusing faster. So that's the reason they will meet at point C,
Hmm.
and they would be forming ammonium chloride. So we can see the white precipitate of ammonium chloride, like a white solid. It's a
Yeah.
white solid. So isn't it, if they are asking the confirmatory test for ammonia, why not we are supposed to use HCl, isn't it?
Yeah.
We can use it. But how, what would be the method, of course, in the lab, how we are supposed to test, like further confirm presence of ammonia? So I'm supposed to write, um, I can I can take any glass rod, because of course this is an acid and we have a concentrated acid. So, and ammonia is a gas, of course. Let's say in a jar I have ammonia, in a
Hmm.
jar I have ammonia, so I'm supposed to take a glass rod which is dipped in concentrated hydrochloric acid, and once it would be in contact with ammonia, so the particles of ammonia would be colliding with this glass rod, which are having the particles of hydrochloric acid. So there is a formation of NH4Cl. Okay, so
Yeah.
we would see the formation of the white solid. It's it further confirms that yep, ammonia is there. It's a further confirmatory test. Okay.
Yeah.
Yeah. So what should I write?
Uh, Dip glass rod in concentrated HCl and then dip the glass rod in ammonia solution. Um, this thing. Then formation of white precipitate of NH4Cl is seen, right? Right?
Yeah.
Okay.
Like it's a side reaction, and it's a white solid.
Okay. Okay. Next question.
State the reason for the addition of, okay. Mm, a 1 cm cube sample of an aqueous solution of A mm, was acidified with dilute hydrochloric acid, and a few drops of barium chloride solution were added. White precipitate, of course. White precipitate of it should be barium sulfate
Yeah.
was formed which identified the anion in A as the sulfate ion. State the reason for the addition of like why he acidified the solution A. And what was the solution A
To
by the way?
react with solution A is formation of the cation in
Compound A.
compound.
Dilute sodium hydroxide solution was added drop by drop to 5 cm cube in aqueous solution of A. Okay, unknown. So in solution as 1 cm cube of sample of an aqueous solution of A was acidified with dilute hydrochloric acid. Okay, and then he has done the test
Can
by
you say that
adding barium chloride.
HCl reacts with carbonate ions to prevent with carbonate ions to prevent formation of any other sort of white precipitate.
Yeah, you can say because in the question they have told you that we have two cations and one anion. Two
Hmm.
cations and one anions, right? So
Yeah,
there should be a one anion. So of course that's
yes.
gonna be sulfate because we have confirmed by the addition of barium chloride. So so maybe might be possible that after the adding this reagent there would be the formation of any other precipitate. Okay, it would be any impurity, like if it would be there, it can form the precipitate. So, so to avoid these things, we have acidified the solution. Like if there would be any of the carbonate, because carbonate is also an anion, right? So it can form the precipitate. So how can we remove the carbonate? Because we have learned that any metal carbonate can react with an acid and they are going to form salt, carbon dioxide, and water. So carbon
Yeah.
dioxide in the form of carbon dioxide, it can be removed from that reaction mixture. So,
Hmm.
so I'm supposed to write it's of 1 mark. Uh, Basically, HCl removes HCl removes carbonate ions. HCl removes carbonate ions. Okay, as carbonate ion can also form a white precipitate.
Yeah.
Bottles of solid barium chloride have the hazard label. Okay, give a precaution other than wearing lab coats, safety goggles that would reduce the risk in preparing a solution of barium chloride. Justify your choice.
I told use fume cupboard to
So,
prevent breathing in the
like,
toxic gas.
yeah, like what is this? It's a sample
Toxic.
of toxic. Yep. So they have a lab coat. They have a safety goggles. What they are asking, give a precaution other than this. Okay, so you are saying that fuming cupboard. Yeah,
Fume cupboard to prevent breathing in the toxic gas. Right?
yeah, that's it. So 1 mark. The formula for A, the water of crystallization.
Uh, wait. A includes Fe2 plus. It includes SO4 2 minus. And what else? Ammonia, right?
Yeah,
So N.
we have sulfate as well. And I think so we have confirmed ammonia as well. And what we did, like Fe2 plus, I think, yeah. So
Yeah,
you
Fe2 plus.
knew the two cations that were Fe2 plus, and then we have what can I say, ammonia, and then what can I say, sulfate. But of course, it wouldn't be an ammonia, it would be
It'll be
ammonium.
NH4. NH4 plus,
Yeah,
yeah.
ammonium, that's why. So, mhm.
So Fe, of course, because it will be the central metal ion. So Fe, um, if that is 2 plus, that is 2 plus, if that is 2 plus, um, NH4 bracket, ah, this is hard.
If this would be 4 plus 4 and plus 2 plus 6, right? I'm supposed to write 3
Is,
over there, isn't it?
yeah, wait, no, 3, 6, 5, no, 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 it's still not,
Yeah, it's correct. Minus
4,
6, minus 6, plus 4,
uh-huh.
and plus 2. It would be 0,
Mm,
right?
yeah, okay, 1 second, I'll write that down. NH4. Wait, what if we do, uh, wait, 2 plus, uh, 2, 2, yeah, we can just do 2 plus, and, okay, Fe, NH4, 2, SO4, 2, right?
NH4 2 SO4 2.
Yeah,
Yeah, we can also do this. Yeah, you can do any ratio. You can
yeah,
do any ratio. It would be, but it would be neutral. It should be neutral, I can say.
yeah.
Mhm. Okay, question number 2 says describe a test including the expected observation, which would be positive for both liquids.
React
Okay,
with, uh, DNPH.
D and pH would react with both. Oh, they are asking the both. Okay. Yeah, 2 for D and pH. So what would we observe?
Formation
This
of
is of
yellow
2 marks,
precipitate.
right? Describe a test including the expected observation which would be positive for the both liquids. They are both no, the first one is al. It's aldehyde and another one is
A
I can
ketone.
say yeah,
Form
ketone. Yep.
so formation of yellow precipitate, right?
Yep. So I'm supposed to write addition of 2,4-dinitrophenyl hydrazine in a sample. So formation of what?
For yellow precipitate, yeah.
Orange precipitate, not yellow.
Oh, okay, fine.
Yellow precipitate is the iodoform test.
Okay.
Describe two chemical tests, including the expected, which age give a positive and no other, and no reaction with butanol. Like with
So
ketone, no reaction. With aldehyde, there is a reaction.
so first one is react with tolerance reagent, and
Good.
positive result is formation of silver mirror, right? And then for the second one, react with Felling's reagent. The positive result is formation of, sorry, no, not formation, is color change from blue to brick red. Blue solution to brick red precipitate, right?
Yeah, so in describe two chemical tests, right? So in
Yes.
test one, I can write I would say that um, like I can use Tollens reagent, and in the presence of Tollens reagent, so there would be the formation of silver mirror. So means that aldehyde is confirmed because Tollens reagent is an oxidizing agent. It can oxidize only aldehyde. Ketone cannot be oxidized.
Yeah.
So test 2 I can write failing solution means Benedict solution. So of course the color of failing solution is blue because it's copper sulfate, or after the react it's also an oxidizing agent. After oxidizing the aldehyde, it would be turning into brick red because copper plus one is formed, right? Cuprous
Yeah.
oxide Cu2O is formed. That's why. So add Tollens reagent and warm the mixture, then formation of silver mirror takes place. Any other test that you can write it down rather than
Yeah,
Benedict
Felling's
solution,
reagent.
like no other than this.
Fe- Oh, okay.
Anything that is in
You
your
can
mind.
also, yeah, you can oxidize with potassium dichromate, and it'll change from no, but both of them will give that. Wait, let me think. Only
No, why?
only
Why both of
positive
them?
result.
No, 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 no. The thing is
No.
that why you are saying both of them? It's a ketone. It cannot be oxidized further.
Oh yeah, yeah.
It's an
My
aldehyde.
bad.
It can give you carboxylic acid, right? So,
Carboxylic acid.
so I am supposed to write
Orange to green.
add K2Cr2O7, right?
Yeah.
And warm, then then butanol will change the color of K2Cr2O7 from orange to green, right?
Mm-hmm. Yeah.
State what is observed when an alkaline solution of iodine is added. Yeah, alkaline aqueous iodine. Iodoform is formed. That would be the white PPT. Sorry, yellow PPT.
Yellow, yellow, yellow. Yeah.
So yeah, I'm supposed to yellow precipitates. High resolution proton nuclear magnetic resonance spectrum. Yeah, see this one. It's of 3 marks.
Oh. Okay. Wait, no. High resolution proton nuclear magnetic text issue.
And
Reduce
it's a high
time.
resolution. Remember, it's a high resolution NMR, right? So you can
Mm.
see this is the singlet
Yeah.
and this is your triplet.
Singlet with a
And
relative peak.
this is for the TMS. And
Yeah.
this is the quartet. Why
Reduce
I'm
iron.
getting singlet? Why I'm getting singlet? Because there is no neighboring hydrogen. Why I'm getting triplet? Because in the neighbor we have two hydrogens. Why I'm getting quartet? Because in the neighbor I have three hydrogen atoms. If you remember, we used to apply n plus 1 rule. If you
Yeah.
remember, we used to apply n plus 1, deduce the identity of the substance. X refer only to the peak with the asterisk, which is a singlet with a relative peak area of 3. Okay.
Mm.
So basically, of X is shown, right?
Uh,
I think so. There is no. Uh, a student was asked to investigate the two liquids labeled X and Y. One liquid was butanol and the other was butanone. Okay, X and Y. This one. Or this is okay. First of all, let me tell you, it would give you singlet, isn't it?
yes.
Yes or no? It would give
Yeah.
you triplet. Huh?
One, two, yeah.
It would give you what? Hmm.
One, two, three, four, five. It'll be sextet.
Yeah, exactly. It's sextet. And it would be giving you what?
Triplet.
Quartet. Sorry, yeah, triplet. Did you see any sextet peak in the given NMR?
No.
No, 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 no. It may be butanone, isn't it? It's a good hint for us.
Yeah.
Yeah. So, okay, okay. This is your singlet. This is your quartet. This is your triplet. Okay. So that's the answer. Three areas. I have three peaks. One, two, three. Okay. So this
Beautiful.
is going to be CH3. That's why they are saying peak area of 3 means 3 hydrogen atoms. Okay.
Yeah.
So area of 3 means what? Area of 3 means what? Area
Number
of
of
3 means
hydrogen
3.
protons.
Yeah, 3. 3 hydrogens. 3 hydrogens having having the same environment. Having the same environment.
Yeah.
Okay. But there is no neighboring hydrogen, so splitting pattern is the same. Okay.
Yeah.
Splitting pattern is singlet. But
Yeah.
I'm supposed to write, but splitting pattern is singlet, as you saw in the given spectrum, as there is no neighbor hydrogen. Okay,
Yeah.
see this one. The proton NMR spectrum has a small peak with a chemical shift that is 0 parts per million, which does not result from substance X. Explain the presence of this small peak, identify the compound responsible.
The proton NMR spectrum has a small peak with a chemical shift, parts per million, which does not result from substance. Explain the presence of this small peak, identifying the compound responsible. Is it TMS?
Yeah, I told you before, right? It's a
Yeah.
TMS. TMS is what?
Uh,
It's a reference peak, right? It's a
tetra,
reference peak. Methyl
something.
silane.
Yeah. Tetramethyl.
Yeah.
What is it? Tetramethyl what?
Tetramethyl. Like it's a silicon. It's a
Hmm.
silicon which is connected with four methyl groups. That's why we are
Okay.
saying tetramethyl silane. So, huh? It's TMS,
Hmm.
which is reference peak. Mhm. Question number three. This question is about the preparation of a complex salt of cobalt. Okay. Deduce the ionic equation for the reaction of hydrogen
Yes.
peroxide with by state symbol are not required. So, of one mark only. State symbols for the hydrogen cobalt 2. Cobalt 2 ions, right? So, cobalt 2. Yeah, they are saying that cobalt 2 is going to convert into cobalt 3. So means that it's getting oxidized. So hydrogen peroxide is an oxidizing agent. Okay. So first of all, it would be cobalt 2 plus 2 cobalt 3 plus, and then this is the equation H2O2 plus 2H positive plus 2E minus. It's gonna give us 2H2O. It would be one electron, isn't it? Because we have to balance the charge. Yes or no?
Yeah. Yes.
I'm going to multiply this equation by 2, by 2, by 2. Then I'm going to add. I would be getting, I would be getting 2 cobalt 2 plus H2O2 2H positive, then I have cobalt 3 plus, then I have 2H2O. That's it.
Yeah.
Show by calculation that there is a sufficient hydrogen peroxide to oxidize all of the cobalt 2 ions.
Okay. Um,
Hmm.
Show by calculation that there is sufficient hydrogen peroxide to oxidize all of the cobalt. Hmm.
So, they are asking, show by calculation that there is sufficient hydrogen peroxide means that it's in excess. It's in excess, isn't it?
Hmm.
So it's the concept of excess reactant
Yeah.
and a limiting reactant. So you have to find out the number of moles first and then you have to decide. So the number of moles of what? The number of moles of things. So they have given you 3.6 gram of cobalt 2 plus, isn't it? It's cobalt 2 plus to 2.5. So first of all, uh, and what would be the number of moles of H2O2? Mm, Did they give us? Yep, 25 cm cube of 3% hydrogen peroxide. 3 gram per 100 centimeter cube. And what they have given us, carefully add. Okay. Yeah. So 3 grams per 100 centimeter cube, right?
Hmm.
And the total volume is 25, remember.
Uh,
It would be X grams. What's the answer?
1 second. If wait, 3 grams. What is
Per 100
so that there
centimeter
is
cube.
sufficient hydrogen peroxide to oxidize all the cobalt ions. So there are 3 grams per 100 centimeter cube, and there is only 25, a total volume of 25 centimeter cube, right? So 3 grams gives 100 centimeter cube, but 25 centimeter cube gives how much? So that means 25% of 3, 25% of 3 is 0.75.
Yep. So 0.75 grams is the mass of H2O2 divided by its MR, that is 34. It's going to give you the mole of H2O2.
Yeah. So that is 0.022, 0.0221. Sorry.
1 mole of H2O2, right?
Yeah, 0.0221. Yeah.
Yep. So then what's the number of moles of cobalt 2 plus so that I can take an idea
So
after taking the mole ratio?
cobalt 2 plus, it is 2.5 no grams of ammonium nitrate at 3.6 grams of hydrated cobalt.
So what's
So
the
if we
MR
take the three,
first so that I can divide it by its MR to get the moles? Then we have to see this.
MR will be, MR is huge. Cobalt 58.9 plus nitrogen will be 14 plus 14 plus 16 plus 16 plus 16 plus 16 plus 6 times 18, 290.9.
290.9.
90.9.
Okay. So mole is equal to, what was the mass? 3.5, right? Divided by
uh 3.5, yes, 3.6, 3.6.
3.6. Okay. So what's the answer?
0.0124. Now, but we need to multiply that by 2, right?
Why?
Because it's 2 moles.
Yep. Or I can say you are supposed to divide it by the coefficient of H2O2, that is 1. you are supposed to divide it by the coefficient of cobalt 2 plus, that is 2. After dividing, if you are getting the less number, it would be the limiting reactant, and if you are getting the larger number, it would be an excess reactant. So of course, after dividing with 1, it would be giving you the same number, and if you are going to divide it by 2 and you are getting what, then you have to decide which is number, which is lower and which is higher. So higher would be
So when
excess
you divide it,
reactant. So of
you get
course H2O2
6
would be higher.
6.188 times 10 raised to negative 3, hence there is
So of
sufficient
course
hydrogen peroxide.
it's yep. Okay. Simple and easy.
Yeah. In step
Okay.
4, when an excess of hydrogen peroxide is added, bubbles are seen, three lights are glowing. Okay, oxygen. Identify the gas and write the formation of this gas, equation for the formation of the gas. Oh. Mm, um,
This one, this one, this one.
H2,
H2O2.
yeah, H2O2, when broken down, will
It's going to
give
give you oxygen.
H,
It's confirmed that it's an oxygen.
yeah,
So then we have to balance this equation, of course, right? It's going to give us H2O because they are saying is added bubbles are seen the gas relights. Identify and write an equation. So it's a balanced chemical equation. H2O to 2 oxygen and 3 oxygen. I'm supposed to write half over there. It's a balanced equation.
yeah.
State the purpose of ethanol in step 6 and why it is cold. Step 6.
Purpose of ethanol in step 6 and why it's cold. Ethanol in step 6, cold ethanol. To remove the soluble impurities,
Mm,
right?
The
This
precipitate
is
to
done to remove the
precipitate the
soluble
complex
impurities.
salt at cold ethanol to the mixture and filter the solid form under the reduced pressure. Yeah, yeah, you can say that. It's of 2 mark, right?
So you can say that the salt is uh
Why it is cold? It's related to the solubility.
yeah, so of course when it's cold the solubility decreases, right?
Yeah, it decreases because solubility is directly proportional to the temperature. Okay, so
Yeah.
solubility will be lower, and of course, the salt is
The wait, the salt is what's the salt? It's
less
CO3 plus,
soluble
which
in
is
ethanol
polar. Yeah.
than water
Uh,
because it's soluble in
water is
water. It's
polar.
polar. Yeah, it's polar.
Yeah.
So that's why we are adding this one, ethanol. So it's having a lower solubility in ethanol. Ethanol is an organic solvent, right?
Yeah.
Okay.